Good day, everyone. So we are still on chapter 1, exponents and sets. So remember last time we did exercise 1 and we did some questions here on exercise 1. So today we are continuing. So today we'll be doing multiplication and division of powers with numerical basis. So actually here we are going to be simplifying as shown on the textbook, and also we are going to be doing addition and subtraction of powers with numerical basis. Can you see that we've got example 4 there? It says that show that this is equals to that. So when they say show that, they are actually saying prove that the left hand side is equal to the right hand side. So we are going to do it just now. So here we are only can you see that on C we are going to simplify, but then we are going to be using the laws of exponents, the one that we did before. So let's just quickly go to exercise 2. Let's just start with 1A. So 1A says that, so it's gonna be 1A, it's 5 multiplied by 2 to the exponent x minus 2 to the exponent x plus 2 equals to 2x, like this. So here, before you do anything, you're going to choose the side which is more complex one. So checking here, we have got the left hand side and the right hand side. So the left hand side, it is more complex, so I'm gonna say left hand side. You're choosing the side that is more complex one. So it's gonna be 5 multiplied by 2 to the exponent x minus 2 to the exponent x plus 2, like this. Then from there we are going to break this. So it's gonna be 5 multiplied by 2x minus 2x. So I'm gonna I will take this part first, then I say multiply by, the dot means multiply by, then 2 to the exponent 2, like that. So this part actually and that part, they are all the same. I did not change anything. Then from there, can you see that I can find 2 to the exponent x here, I can find 2 to the exponent x here. So that means they are that means I have got a common factor. So I'm gonna write a common factor like this, then I open a bracket. So it's gonna be this into this, so it's gonna 2 to the exponent x into 2 to the exponent x is equals to 1. Then that 1 times 5, I'll get 5 minus, then 2 to the exponent x into 2 to the exponent x is still 1. Then that 1 multiplied by all this is gonna be 2 squared. Then from there I'll write 2x open bracket 5 minus, then 2 squared, it is 4. Then from there it's gonna be 2 to the exponent x, then 5 minus 4 is 1. Therefore 1 times 2 2 to the exponent x times 1 is 2 to the exponent x. So this is my answer. Can you see that 2 to the exponent x and 2 to the exponent x, the left hand side one and the right hand side one, they are the same. So therefore you are going to say left hand side is equals to right hand side, like this. So this is how we prove. So let us go to another question. Let's see the one that we can do now. Let me choose the one that seems to be more complex one. Okay, so let's choose let's go to 1C now. I think this one is a bit challenging, so let me choose that. So this one, it's so it's 1C, ne? Let me do like this. So it's 1C, it's 2 to the exponent 2x minus 1 plus 4 to the exponent x plus 1 equals to 2 to the exponent 2x open bracket 9 over 2. So here what we are doing, we are still proving actually. So when they say prove that, it's like prove that the left hand side is equal to the right hand side. So, and I said before that we are choosing the more complex one. So can you see that my left hand side, it seems to be more complex. So I'm going to write the left hand side. Before I do anything, I will copy it the way it is. I don't change anything. So it is 2 to the exponent 2x minus 1 plus 4 to the exponent x plus 1, like this. Then from there, what we are going to do, so now what we're going to do, I can see that 2 is already simplified, so I'm gonna write it as it is on the bottom. It's gonna be 2 to the exponent 2x minus 1 plus, but then I'm going to change that 4. I want to find the prime basis of 4. So what you're going to do, you take your calculator, then you write 4 equals 2, then you shift, then fact. So it's gonna be 2 to the exponent 2, like this. So therefore it's gonna be 2 to the exponent 2, but because we already have exponents there, you're going to open a bracket like this, then you write x plus 1, like that. From there we remove the bracket. It's gonna be 2 to the exponent 2x minus 1 plus, so remember this 2, it is multiplying this x and it also multiplying this 1, so it's gonna be 2. I'm gonna write the base first, then 2 times x is equals to 2x, 2 times 1 gonna be plus 2, like this. Then what I'm going to do, I'm going to break it. I'm going to break this part and that part. So I'm going to take this part first. It will be 2 to the exponent 2x multiply by, then I go to that part, then multiply by 2 to the exponent negative 1 plus, this is the plus, this is the plus. Then I will take this part first, 2 to the exponent 2x, then I'm going to that part where there is 2 multiply by 2 to the exponent 2. So this and this, they are the same. This and this, they are the same. I did not change anything. Then from there, can you see that we have got the 2 to the exponent 2x here on here, and we've got 2 to the exponent 2x on here as well. So it tells me that, or it tells us that we've got a common factor. So I'm going to write that as my common factor, 2 to the exponent 2x, then I open a bracket. This 2 to the exponent 2x into 2 to the exponent 2x is 1, then that 1 times this is going to be 2 to the exponent negative 1 plus, this is the plus, then 2 to the exponent 2x into 2 to the exponent 2x is 1, then that 1 times this is going to be 2 squared. From there I write the 2 to the exponent 2x here, then I open a bracket. So remember, I'm going to change this. It's going to be 1 over 2 plus, then 2 squared is 4, like this. Then from there it's going to be 2 to the exponent 2x, open a bracket. I'm going to, this one is a fraction, this one is not a fraction, you make it a fraction like this. Then you find the lowest common factor of 2 and 1, which is 2. Then 2 into 2, it goes once, then that 1 times that times this one is 1, plus 1 into 2 goes twice, then that 2 times 4 is 8. Therefore from there we add 2 to the exponent 2x, 1 plus 8 is 9 over 2, like this. Can you see that this here, it is the same as this here? So if they are the same, we are going to say left, therefore left hand side is equals to right hand side, like this. So this is how we prove, guys. This is how we prove, this is how it's done. So let's choose another one, the one that seems to be more challenging again. So I'm gonna go with 1e. So 1e, it says 2 to the exponent 10 to the 2 multiplied by 10 to the exponent x minus 5 to the exponent x plus 1 multiplied by 2 to the exponent x equals to negative 3 multiplied by 10 to the exponent x. So this is how it is. So before you do anything, as I've said before, you are still choosing the side that is more complex. So at this point I can see that the left hand side seems to be more complex, so I'm gonna write left hand side. Before I do anything, I'm gonna copy the way it is. I'm not gonna change anything. It's gonna be 10 it's gonna be 2 to the 2 multiplied by 10 to the exponent x minus 5 multiplied by minus 5 to the exponent x plus 1 multiplied by 2 to the exponent x, like this. So from here we are going to find the prime basis of 10. So what you're gonna do, we're going to do the same thing. 10 equals 2, shift, then you go to fact, like that. So it's gonna be 2 multiplied by 5, so it's gonna be 2. So because there is an exponent over there, we open a bracket. It's gonna be 2. The dot means multiplication to the exponent x, or is to all of them are 2 and 5 to the exponent x, minus 5 to the exponent x plus 1 multiplied by 2 to the exponent x, like this. Then from there we are going to let us break this 5. So if we break the 5, it's going to be 2, open a bracket, 2 multiplied by 5 to the exponent x minus 5. I'm going to take this part, so it's going to be 5 to the exponent x multiplied by 5, like this, multiplied by this one now, which is 2 to the exponent x, like this. So from there, for this part only, I'm going to since they are sharing an exponent like this, I'm going to put them in a bracket. So it's going to be 2, open a bracket, 2 to the exponent 5, close bracket, x minus since this they are sharing an exponent like this, so I'm gonna write 5, this 5 out, then I open a bracket, I write 5 here, multiplied by 2. Since they are sharing an exponent, I'm gonna write x, like that. So it means I can still break this part, the whole part, to be here, so to be like this. So this and this are the same. I did not change anything, and you can see that this part, it is also on it is also on this part. So this becomes our common factor. So I'm going to take out the common factor, which is open bracket 2 multiplied by 5 to the exponent x, then I open a bracket again. Then this into this goes once, I'll be left with 2. So it's gonna be 2 here, minus, this is the minus, then this into this, it will cancel, I'll be left with 5, like this. So I'm gonna write my 5. Then from there, what I'm going to do, I'm gonna say 2, open bracket, 2 multiplied by 5, close bracket, x, 2 minus 5 is gonna be negative 3, like this. Then from there, I'm gonna say 2 times 5, so 2 times 5 is gonna be 10 to the exponent x negative 3, like this. Then from there, I can remove the bracket. That means I'm gonna first remove the bracket here. Remember, since there's no any exponent on 10, so we assume that it's 1, like this. So it's gonna be 1 times x is gonna be 10 to the exponent x, open bracket, negative 3. Then from there, we remove the brackets by multiplying. It's gonna be 10 to the exponent x multiplied by negative 3. It's gonna be negative 3 multiplied by 10 to the exponent x, like this. So guys, you can see that my left hand side here is equals to the right hand side here. So therefore, left hand side is equals to right hand side. So this is how we do it, guys. You're gonna forgive me because today it's raining. I hope it is clear. Okay, so now we're going to choose another question that is a bit challenging, like this one as well. So remember, we did 1E. So now let us try to do 1F. So still on exercise 2. So 1F goes like this: 4 multiplied by 3 to the exponent 1 minus x plus 3 to the exponent 2 minus x equals to 21 over 3 to the exponent x, like this. So as I've said before, that we're still choosing the side that is more complex. So at this we are going to choose the left hand side now. So we are going to say left hand side. So before we do anything, I'm going to write the left hand side as it is, since it is the one that seems to be more complex. So it's gonna be 4 multiplied by 3 to the exponent 1 minus x plus 3 to the exponent 2 minus x, like this. So what we're going to do now, we're going to break this, and we also break this, the base. We're going to break this, and also at this. So it's going to be 4 multiplied by 3. I'm going to take this part first. It's going to be 3 to the exponent 1 multiplied by the base 3 to the exponent negative x plus 3 to the exponent 2 multiplied by 3 to the exponent negative x. Remember, this part here and this part here, it is the same. This part here and this part here, it is the same. I did not change anything actually. So what I'm going to do, I only changed so that I can find the common factor. Can you see here? We've got the base 3 to the exponent negative x, the base 3 to the exponent negative x. This and this, they are said to be a common factor. So we're going to take out a common factor. So it's going to be 3 to the exponent negative x, open a bracket. So we're going to say 3 to the exponent negative x into 3 to the exponent negative x. I'm going to get 1. Then that 1 times all this, I'm going to get 4 multiplied by 3 to the exponent 1 plus, this is the plus. Then from there, I'm going to say this 3 to the exponent negative x into 3 to the exponent negative x. I'm going to get 1. Then that 1 multiplied by 3 squared is going to be 3 squared. From there, I'm going to solve what is in the bracket. So I'm gonna bring down the 3 to the exponent negative x. So remember, 3 to the exponent negative 3 to the exponent 1. It is 3. That 3 times 4, I'm gonna get 12. Plus 3 squared, it is 9. Whilst I'm still dealing with what is in the bracket. So I'm going to say 12 plus 9, I'm going to get 21. As I've said before, that can you see that this exponent, it is negative? And I said that we always try to make the exponents to be positive at all time. So at this point, we have got a negative exponent. So I'm going to make this a fraction. By making it a fraction, I'm going to take this negative exponent down there. So it's going to be I'm gonna leave 21 on top. So I leave 21 all over. I'm gonna take this down there. It's gonna be 3 to the exponent x. So as it goes down there, it loses the negative and become a positive, like that. So you can see that this is my left hand side is equals to the right hand side here. Can you see that the left hand side here is equal to the right hand side? Therefore, we are going to conclude by saying, therefore, left hand side is equals to right hand side, like this. So this is how we prove, guys. So I would think for now we're gonna leave it here. So that the video becomes a little bit smaller, so that you also understand, so that you get a time to refresh yourself. Thank you very much for watching.